welcome back, everybody. Sorry, I accidentally started the video a little bit late. We're looking at these sequences here. The key here for these sequences is I am not telling you what type of sequence it is. You have to tell what type of sequence it is, and then tell me what the equation is. All right, so Tommy correctly pointed out that we have a +3 pattern. Each time we have a +3 pattern, and he said that's arithmetic. So I know that it's -2 plus, and then we have our n. Remember, leave n in with the equation. And then it's times d. So what do I put next to this, Tommy? Times what? 1. Oh, be careful. 3. That's your d. Times 3. So there's my equation. Whenever I ask you for an equation, that's what I need to see. N still plugged in. Now, if you have friends in Mr. Delap's or Mr. Westfall's class, they actually, they have to do more work on this. They distribute it in and simplify. I'm not going to make you do that because if you put this answer in the box in the end of the course test, you're still going to get it right. Yeah.
Is there any shot you can hand me a calculator?
No, you have to get up and get it. Now, for Geo, for a sub 11, what is that telling you to do with that a sub 11?
No, you got.
Shit. What's that telling you to do with 11?
Is it to put it to the 11th power?
Nope. You got to plug it in for n. 11 goes in for n. So that means -2 plus 11 minus 1 times 3. So the 11th term in this sequence is 28. So that sub means that's what n is. Plug that number into that equation. The
so it would be the same for the second one too, since it's a sub 11.
Exactly. Brianna?
I got -60.
You got -60?
Yeah.
What?
I
Take a look at your equation and make sure that it's correct. Then try plugging it in again. Because maybe you just punched the number as wrong. Maybe you put a times instead of a minus or something.
I got 25.
Again, look at it in your equation. Look at it in your calculator because I think that's correct. Nathan?
So after I plugged it in, I understand how you got your answer, but I just solved mine a little bit more, I guess. And in the parentheses, I put 10 plus, or -2 plus 10. So I got 8 and then did times 3, and I didn't get 28. You see what I'm saying?
No. You got 30. 11 minus 1 is 10 times 3 is 30. Plus a -2 is 28.
Yeah, but like I solved it more and then like.
Well, then you did some wrong math somewhere in there. Yeah.
I don't know what it's doing different. Like I did 11 minus 1 and I just put 10 in the first time, but I still got.
No. Okay, questions on that? All right, let's take a look at the next one. Now, Solomon, what is this? Is this number 2 arithmetic or geometric? Geometric. Why do you say it's geometric? Good. Now, what am I multiplying by, Solomon? Good. And I'm glad he said -5. Now, remember that if you are struggling with finding the ratio, the ratio is always a sub 2 divided by a sub 1. So in this case, -5 over 1. So -5 is my ratio. Honestly, you could do that with any 2 terms. Take the second term divided by the first term. Take the 5th term divided by the 4th term. Take the 8th term divided by the 7th term. It should be consistent throughout if it's geometric. Now, Solomon, what is a? So now that tells me I use this formula. What is a sub 1 in this case? And then my r. Now be careful here. When you put your r in, please put it in parentheses. Your r is -5. Okay, sorry, I kind of stole that one from you. Your r is -5. Please put it in parentheses, especially when you do it in your calculator. Raised to the n minus 1 power. Now, when I find a sub 11, remember that when I plug this in, I'm going to have 1 times -5 to the 11 minus 1 power. I'm going to go in my calculator, and I'm going to say 1 times -5 in parentheses raised to the what power? 10. 10. Don't do 11 minus 1 in your calculator. If you do, what should you use? Parentheses. I mean, it's okay to do that, but honestly, 11 minus 1 is just 10. So use that. Ooh, big number. Don't be afraid of big numbers, especially in geometric sequences, especially exponential functions. Do not be afraid of big numbers or really small numbers. 9,765,000. And then 625. Gio, what's your question?
Well, that just doesn't make sense because you put like on like the last one you said to put like 11 minus 1, then that one you just have minus 5. Like that don't make no sense.
Doesn't make
What do you mean? Because one is arithmetic and one is geometric. They're two completely different problems.
How
This one is arithmetic because I'm
Where the
constantly
differences?
adding.
on the right.
Let me explain it. This one is arithmetic because I'm constantly adding. This one is geometric because I'm constantly multiplying. That's the problem here. You've got to be able to tell the difference between the two so that you know which formula to
Is
use.
it geometric if it's division?
Yeah, but remember that we're going to think about it as multiplication only. Okay, multiplication only. If you see division, it's geometric, but you have to multiply by whatever a sub 2 divided by a sub 1 is. Okay, that's why the -5 and the n minus 1 have nothing to do with each other. The -5 comes from the ratio. The n minus 1 in here comes from the formula. They're just completely different things. Okay, Sydney? Yeah. Any other questions? Yes, on the warm-up.
I must have done something really wrong because I got -49.
Yes, then you did something very wrong. I don't know. Guys, stop telling me like I did something wrong. If you have a question, that's fine. But you guys that say like I got this. Okay. I don't know how you got it. Can't see your paper. Can't see your calculator. Don't know what you punched. Okay. Make sure that you're asking questions like, okay, where did you get that number? What did you do here? That's a better question. What questions do we have on the homework? Nathan.
Can we go over number 5?
Yeah. Looking here, number 5, find the common ratio of the sequence here for number 5. For this one, remember that the ratio is always equivalent to a sub 2 divided by a sub 1. So in this case, 96 over 128, which in this case is, 96 over 128.75. Does that make sense?
Yep.
Ron?
27 or 28.
You pick.
27.
Okay. So for 27, now I'm told for all of these, because this was the geometric sequence homework, I am told for all of these that these are geometric sequences. So I can go straight away. I don't even need to like check the pattern. I know that they are geometric sequences. You said 27, correct? 27? Oh, yeah. Okay, so that means if I need to find the ratio is equivalent in this one to 764 over 7,640. So let's see what that comes out to be. 764 divided by 7640, which is 0.1. 0.1. So my ratio is 0.1. I know that this is geometric, so I'm going to use this formula. So I say a sub n is equal to a sub 1, which is 7640. The ratio to the n minus 1 power. There's half of my answer. See, for those of you who just wrote a number, this is why that's wrong. I need to see the full equation. That's part of your answer. And then it says, then find a sub 6. Okay, 7640, 0.1 to the 6 minus 1 power. So when I go into my calculator, again, I'm going to do 7640 times 0.1 raised to the what power am I going to use? 5th power. Do that minus 1 in my head. 5th power, so 0.0764. Honestly, multiplying by 1/10, aren't I just like moving the decimal place 1 unit each time?
Mm-hmm.
Yeah.
And you did 764 over that because it's 8.
A sub 2 divided by a sub 1. Yep. Second term divided by first term. And again, honestly, I could have taken fourth term divided by third term as well. 7.64 divided by 76.4 should give me the exact same ratio. of 0.1. Doesn't matter. Just take 2 terms and divide. Just make sure you do the second one divided by the first one, third one divided by the second one. Go backward in order. Are there any other questions on the homework? Yeah, Brianna?
7 through 12 and
Any of those you pick?
like
9 or 10. Okay. So for not, I'm just saying, okay, is it arithmetic, is it geometric, or neither, basically, right? So looking at 9, think about this. It's either got to be adding the same thing as my first 2 terms. Like, how much am I going up between 9 and 14? Plus 5, right? Does that pattern continue? No. So we know that it's not arithmetic. Then you take a look at, okay, 9 is 14 divided by 9. A sub 2 divided by a sub 1. Okay, this is what I'm going up by, right? If I multiply that by 14, I should get 20 if this is geometric. So is it geometric either? No. Yeah, same type of thing there. I take 3 49s. I'm going to do this in parentheses. I'm sorry. I guess I could think about it this way. What's the difference between 3 and 21? What's the difference between 3 and 21? 18. Is that the same difference there? So it's definitely not arithmetic. You know, like I'm not going 18 down to go to 3 sevenths. So this only has the possibility of being geometric. So if I take 3 sevenths, a sub 2, divided by a sub 1, 3 49s, that gives me 7. Am I constantly multiplying by 7 each time? What if I multiply that by 3 sevenths? Do I get 3? Yeah. 3 times 7, is that 21? Yeah. So that's where I see that this is geometric. Any other questions on the homework? Okay, so let's take a look at our guided notes for today. Now, I want to stress to you guys that we are not learning a new sequence today. We've learned the 2 of them. There are only 2 of them. But what we are going to learn today is another way to write sequences. Okay? That's what we're going to be looking at today. Another way to write sequences. Yep. Now, in my mind, I wasn't thinking that these are new formulas. But last period, they were like, oh yeah, I'm going to have to memorize that. I said, oh, okay. So they're actually up on the board already for you. But, I mean, spoiler alert, they're on the page, but we're getting it now as well. So you might have to memorize these, but some of you are going to be like, no, that's simple. I don't need to memorize that. That's pretty self-explanatory. Okay, let me ask you. Let me start the day off by saying this. In an arithmetic sequence, what are you constantly doing? Adding, right? Or subtracting, but adding. Let's say adding. So if I have my first term, how do I get to my second term? You add, say my common ratio was 3, right? I would add 3. What if I was at my 6th term? How would I get my 7th term?
Add 3 again.
Add 3. But I could just add 3, right? If I was sitting at my 6th term and I knew my 6th term, to get to my 7th term, I would just add 3. What if I was at my 411th term? I knew the 411th term. What would I do to get my 412th?
Add 3.
Add 3, right? That's basically what a recursive formula is. You have to know the term before it. And if you know the term before it and the difference, or the ratio in that matter, if you know the term before it, you can obviously get to the term next to it. All terms go in order, right? They're all sequenced. So, like for an explicit rule, we hadn't even talked about them in this terminology, but this is an explicit rule. These are explicit rules. What does that mean? That means that I could find the millionth term. Do I need to know any of the other terms other than the first term? No. All I need to know is the first term and whatever my difference is. That's called an explicit rule. What if I needed the 750th term? Could I find it if I was given the first term in the ratio? Yeah. Now, if it's a recursive, you can't do that. Okay? So recursive is a little bit more restrictive. Recursive, basically the word recursive implies that I'm going to be looking directly in front of that term. So how do I get the 10th term? Well, you need the 9th term. If I need the 70th term, well, you need the 69th term. If I want the 412th term, well, I need the 411th term. That is what's called a recursive equation. And here's what they are. I wrote them up here on the board as well, just in case you need them throughout the day. But basically what I say is a sub n is equal to a sub n minus 1. Well, what does that mean? What does a sub n minus 1 mean? What does that mean? Can somebody tell me? What does a sub n minus 1 mean? That's a sub n. Like, that's the term we're trying to find. What does a sub n minus 1 mean?
The term that you're trying to find in this one.
Right, so the one directly before it, right? A sub n minus 1 means you know the term you're looking for? The one right before that term. So it basically says any term, you can take the one right before it plus your difference. Well, duh. That's what an arithmetic sequence is, right? You can take the term right before it and add on your difference. Or subtract away your difference, whatever it may be. Okay, that's how you build an arithmetic sequence. But that's just writing it recursively. For geometric, okay, how do you take the next term? Well, you just multiply by your r value, right? So if you're constantly multiplying by 4, well, if I need my 7th term and I want to find or if I have my 7th and I need to find my 8, just multiply by 4 to my 7th, right? If I'm looking for my 10th term, just take your 9th term and multiply it by 4. But you have to have the one before it. So r is your ratio, a sub n minus 1 is the one right before it. So it's r times a sub n minus 1. R times the term directly before it. Now, recursive formulas, they're kind of like, I don't know, I like explicit formulas so much better because you could find any term at any moment. Recursive formulas, they're way more restrictive. Like if I want my 10th term, you got to know your 9th. And to know your 9th, you got to know your 8th. And to know your 8th, you got to know your 7th. And the 7th, the 6th, the 6th, you got to have it all built out, okay? See, we have never taught recursive formulas. This is actually the very first year that we are teaching recursive formulas. You want to know why? Because we've been seeing them come up on the end of course tests. And the recursive formula is actually a really simple formula. But if you don't know what that word means, if you don't understand that recursive formula just means, okay, just put a sub n minus 1 plus your d, or r times your a sub n minus 1, then you don't know how to do it. So that's really all we're doing today. Just looking at it and kind of getting used to the wording a little bit. Now, for recursive formulas, I always have to give you a sub 1. To build your equation, I always have to give you a sub n minus 1. Or sorry, a sub 1. And then I'm going to give you a formula that has a plus or minus or a times. So let me ask you this. I'm only asking you whether these are arithmetic or geometric. Let me ask you this. What is the formula telling you to do to each term? Look at the formula on the right side. What is the formula telling you to do to each term? Add 5. It's telling you, okay, whatever term you need, take the one right before it and add 5. Is that arithmetic or geometric?
Arithmetic.
That's arithmetic.
Did you just say you're adding 4?
No, because those things, that's not a real minus 1. That's just taking the term before it. That is arithmetic. Okay, that is arithmetic. Why is it arithmetic? Because this, the plus or minus about it, means that it's arithmetic. If you see plus or minus, you think arithmetic. All right. What about this next one? You see multiplication by what? By 4, right? Okay, so if it's multiplication by 4, that right in there tells me, oh, that's geometric. Whatever I do, if I want my 10th term, I take my 9th term and I multiply it by 4. This is what a recursive formula will look like. For every recursive formula, you're going to need to be given an a sub 1 and then a rule to follow. You have to have a starting value, and then you have to have a rule to follow. Now, did our a sub 1s mean anything telling us whether it was arithmetic or geometric? No. The only thing that tells us whether it's arithmetic or geometric is the actual rule that we need to follow. Plus or minus means arithmetic, times means geometric. So let's start building out some sequences. We're going to write the first 6 terms of these sequences. Now, I have seen problems like example 2 and example 3 come up on the end of course test. That's why we're starting to teach it now. We thought it was just going to be on for a couple years and go away. No, they're not going away. All right, first 6 terms. Well, what's my first term? 2. I don't even need to read the rule to tell me that this is a 2. Okay, what's my next term then? Henry?
It would be 5.
It would be 5 because what is the rule telling you to do? Add 3 to it. Oh, okay, that's really simple. And then what?
8.
Then, okay, I need 6 terms. 1, 2, 3, 4, 5, 6. Again, you don't need your ... because, again, I only asked for 6 terms, but we should know that it's there. It's going to continue. That's what a recursive rule looks like. Yeah, I've seen examples just like that. But if you have no idea what this is talking about, then you have no idea what the terms are going to be. This is telling you, start at 2, add 3 every time. Yes, Nathan.
I'm just confused on why a sub 1 is equivalent to a sub n now.
It's what I don't understand what you're saying.
So in the beginning of the problem, it says a sub 1 equals 2.
Yes.
So if you plug that in for a sub n minus 1, right?
Mm-hmm. So this is basically saying this. If I want the second term,
Yeah.
then I take, right? Right?
Yeah.
So a sub 2. What is a sub 1?
Oh, 2.
Don't get confused about that 2 and that 2 being the same thing.
Oh.
That's just coincidental.
Oh, okay.
Okay? You could do that for every term you needed to, but you have to know the one before it. You know? If I wanted the 7th term, well, I could take a sub 7 is equal to a sub 6 plus 3. And keep it going. All right, so let's build this equation. For example B, is this going to be arithmetic or geometric? Geometric because I see 3 times, right? Where's my starting value? 1. And then I'm just going to multiply by 3 each time. Jeez, oh Pete. Let's try it again. Okay. So 1 times 3 is 3, times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. How did I know it was times 3? Well, I looked at the rule. It was 3 times a sub n minus 1. 3 times my previous term. Looking at example C, is that going to be arithmetic or geometric? Example C is arithmetic. You got it. Because of the minus 4. The minus 4. This is arithmetic. So I start at 6, and then I just keep subtracting 4. Oops, I wrote a minus. Oops. So 2, negative 2, negative 6, negative 10, negative 14.
The other board is
frozen. Never mind.
Sorry. Yeah.
Can I do the next one?
Yeah, so D.
So
Where do I start?
it's 32.
Okay, and then what's my next term?
1/2.
Half of 32.
Yeah. So it would be like times 1/2.
Yeah,
Times
so
1/2. And then times 1/2.
exactly. So 16, so 8, so 4, so 2, so 1, and there's my 6 terms. Okay? Questions about that? That's what a recursive formula looks like and works. Now, I hope we can say, okay, that's not too bad. You just have to know what the problem is telling you, right? If I never taught you what a recursive formula is, you'd look at that and go, that looks gibberish to me. I don't know what it's talking about. So let's flip it now. Let's take the equation and write it recursively. Write a recursive rule for the sequence. Again, it's simple. For every recursive formula, you should write an a sub 1 equals. Then you can either leave space, I'll do the semicolon, and then write an a sub n equals. Okay, so pretty easy. What is a sub 1 in this case? A sub 1 is 8. Now we have to decide, is this arithmetic or geometric? Arithmetic. What am I constantly doing? Subtracting by 5. So I'm gonna use this. I'm gonna say a sub n minus 1 minus 5. Done. I don't know why I left so much of a space there. But. So every time you need an a sub 1,
Okay.
that's a semicolon.
Nice, Tom.
And then an a sub 1 and then an a sub n is equal to. So for example here, next one. Now be careful. What's my rule?
Would it be like plus 1.3?
Yeah, you might be tempted to say times 2. Because look at your first two terms. Isn't 1.3 times 2 2.6? But is 2.6 times 2 3.9? No. So this is not geometric. This is actually arithmetic. I'm adding 1.3, not times by 2.
So a sub 1 would be 1.3.
So let's write it. A sub 1 is 1.3, semicolon. A sub 1 is, and then a sub n is equal to, okay, since it's again arithmetic, I say a sub n minus 1 plus 1.3. Again, this is a really easy way to write the equation. But what if I had asked you to find the 750th term? Could you do that with this?
Yeah, yes.
Okay, what would you plug in? A sub 750 is equal to a sub 749. Do you know the 749th term? Then you can't do that with the recursive rule. I would have to go back and write the explicit rule to find each term. That's why we never taught recursive rules, because it was kind of like, it's silly. Like, you just got to know what the rule is, and just there it is. But it keeps showing up, and if you don't know what it looks like and you don't know how to work with it. All right, what's my rule here? What am I doing? What's my pattern?
Times 6. Times 5.
Times 5. So a sub 1 is 4, and then a sub n is 5 times the term before it. 5 times a sub n minus 1. Okay? Shh. Questions about that? Yeah.
I'm not sure why you need to put like the n minus 1 at the end of everything.
You got to. Because this is saying 5 times the term before it. Just a rule. You just got to do it. You just got to.
But like, what sense is like? Does it add? Some
Because
joy
that
to,
it's
like,
telling the reader, whatever term you want to find, you have to do 5 times the one that's directly below it, directly to the left of it. So if you want your 70th term, you take 5 times your 70 minus 1 term.
So the 69th.
Right. So you take 5 times that previous term. That would get your 70th term. Let's take a look at D. What's my pattern, Tommy?
+7.
Plus 7. So a sub 1 is negative 10. A sub n is plus 7. A sub n minus 1 plus 7. And then my last two problems are just tables, just presenting in a different way. I mean, still, this is the exact same thing.
That is not efficient. It looks so
It's just the term on the top.
What's the pattern in Tommy? Look at the bottom. What's the pattern in the bottom?
Oh, 1, 2.
What's the pattern in the bottom at the top?
What
What am I doing? What?
Wait.
That would have been negative 15 if that was negative. What am I adding?
Plus 12.
Good. Thank you, Noah.
He said 1/2, so I had to
Plus 12. So a sub 1 is negative 30. A sub n is a sub n minus 1 plus 12.
Something broke while I was wearing it, and it's all over the floor.
Oh, yeah.
I'm still listening.
Questions about that? And then we do the next one here. Now, be careful. I mean, I know a sub 1 is 500. Like, that's always standard, whether it's arithmetic or geometric. And we got to say a sub 1, a sub n is equal to. Okay, what's happening here? It's divided, but be careful.
What's 1 by 1/5?
Yeah, I've got to think about it as, like, what's my ratio? A sub 2 divided by a sub 1. 0.2. So it's 0.2 times a sub n minus 1.
Wait, you switched this time.
What?
No, we did not.
Well, no, I'm saying like I usually put you usually put like a n minus 1 times the number.
Not for geometric. For geometric, I always put the 1 right before. It's always before it. For arithmetic, I do it after. Okay, Nathan.
Did you write 1/5 a to the n?
That's fine too. Yep. Now, here's the deal, though, Nathan. Look,
Overwhelmed.
it was given to me as decimals, so I would say
Would you mark that wrong?
I would not. But if this was like on an end of course test, be careful about that. Yeah. I want to hand back out. I'm going to turn off the video. I need to hand back, guys. I need you to be quiet, please.